in addition to the molecular compounds, we also have ionic compounds which form between cations and anions. So since opposite charges attract, cations and anions bind together to form ionic compounds. There's a differentiation between these ionic compounds and molecular compounds. So generally, if we have an ionic compound, it's formed between a metal and a nonmetal. A molecular or covalent compound forms between a nonmetal and another nonmetal. So this gives us a way to differentiate between these two, and we'll talk about the bonding of each of these in later chapters, but we can kind of use the periodic table as a guide to predict which compounds are going to be molecular or covalent and which ones are going to be ionic. The metals are located on the left-hand side of the periodic table, while the nonmetals are going to be on the right-hand side of the periodic table. So we also need to know the charges of these ionic compounds, or the ions that form these compounds, because it's going to be very, very important in the chemical properties of how they bind together. So let's use the periodic table as a guide to predict how we could use the charges of these ions, or to be able to predict the charges of these ions. So if we do a general sketch of the periodic table, we can kind of chunk it, compartmentalize it into a couple groups. So with our periodic table, we can kind of represent it kind of like this. And I'll draw certain sections here. The transition metals are here in the center, and we're going to kind of ignore these for a second. But the different groups of the periodic table, starting from left going over to the right, we can say the leftmost group is 1A, the second group is 2A, then we have the transition metals, then 3A, 4A, 5A, 6A, 7A, and 8A. We classify elements in the periodic table in groups because they're going to have different reactivity properties, and sometimes they're referred to as families. One of the things about each of these families is they have the same charge. In group 1A, they're going to form cations with a +1 charge. In group 2A, we form cations with a +2 charge. Group 3A also forms cations with a +3 charge. Group 4A is kind of special or kind of different because these are typically neutral. And carbon is in group 4A, and it actually has its own special branch of chemistry called organic chemistry, which we'll briefly touch on the chemistry of carbon, but if you go on to take organic chemistry, you'll take a whole entire year studying the chemistry of carbon. Now, as I'm going to skip over to the right-hand side of the periodic table here for a second. Group 8A is referred to as the noble gases, and they're also neutral and unreactive. So in terms of forming ions, the noble gases do not form ions. For group 7A, these are going to form anions with a -1 charge. Group 6A forms anions with a -2 charge, and group 5A is going to form anions with a -3 charge. So this is going to give us a template to use to figure out what the charges of each of these cations and anions are, and it will give us an indication of how these complexes or these ionic compounds form. So, for example, one of the most common ionic compounds is sodium chloride. Sodium chloride's chemical formula is NaCl. And whenever we have ionic compounds coming together to give us a formula, we need to balance out their charges. In this case, sodium is in group 1A, so it has a +1 charge. Chloride is in group 7A, so it's going to have a -1 charge. So to balance out these charges, we need 1 sodium and 1 chloride. So 1 sodium cation and 1 chloride anion. This is a fairly straightforward case. I think everybody's seen the symbol NaCl before. But what happens if we have an ionic compound like magnesium nitride? If we look at the periodic table, we can find magnesium as element number 12 in group 2A. So magnesium is going to have a +2 charge. Nitrogen is element number 7, so the nitride anion will be contained in group 5A, which has a charge of -3. Ionic compounds come together to balance out their charges. So in order to do so, we need 3 Mg2+ cations plus 2 nitrogen 3- anions to form our ionic compound. So the resulting compound is going to be Mg3N2. And the next section that we're going to look at is titled Nomenclature, where we can come up with a method and a way to name each of these compounds and to figure out what we have present in these ionic compounds as well as the molecular compounds.